Hello all, welcome back to the channel. In the last video we discussed about divide and conquer method. That is how the divide and conquer method works and what are the steps involved in it. And today's video is about divide and conquer applications. So here some of the applications are listed and that is binary search, merge sort, quick sort, star sense matrix multiplication, finding the maximum and minimum of a sequence of numbers. And in this video I'll be discussing about binary search application. So coming to binary search, first we'll see what is a binary search. So binary search is basically a searching technique where you're going to search for some element in the array. So you're given with the array, and in this array if I want to search for any element in it, then I have to find the element, like what is the position of that element. So that will be done with the help of this binary search. And why binary search? So we already have a linear search method, but still why we are going for binary search is in order to reduce the time complexity which is taken in linear search. So if we have linear search, if I want to search for any element in the array, I need to start comparing the value from first position and then I have to move forward, until I find that particular value in the array, which means I need to iterate over these elements for n times if n number of elements are present in the array. That is the drawback of linear search. So that is why we have binary search, where you don't want to search each and every element in the array. Okay, no need to compare with each and every element in the array. Instead, we are going to take one particular value, then you are going to divide your array into subarrays. Then only you are going to compare, like search for the value in that subarrays instead of searching the entire array. So that is how binary search works. We'll see how this happens. Okay, first let me have some key value. I need to search for some key value. So let me take that key value as 52, which is present at the last position of our array. So how do I search for this key value 52? By using binary search. So one thing you want to make sure when you are performing binary search is you have to check whether the array is in sorted order or not. Okay, always the array should contain the values which are in sorted order. Okay, only then you can go for performing your binary search. If the elements are not in sorted order, first you need to do sorting on those elements. After that you can go for applying binary search. So in this example, all the elements are in sorted order which are arranged in ascending order. So I need to check for the element value, that is 52. Where do I start my comparison? As unlike linear search, you are not going to search from the first element. Instead, you need to find the middle position of your binary search. So if you see here, this array value starts from here, that is 2 is 0, then 1, 2, 3, 4, 5, 6. So totally there are 7 elements in this array. If I want to find the middle position, then this is my middle position, that is index value 3 is my middle position. So from here I am going to search for the value 52. Okay, so first step is you need to compare this middle value with this key value. If both are equal, just return the value as result. If it is not equal, then again you need to check for two conditions. One condition is whether this key value is greater than the middle value or the key value is less than the middle value. If you check this array before this 16, you can see all the values are lesser than this middle value, and after this all the values are greater than this value. So left hand side completely lesser values than middle value, and right side completely greater than the middle value. So based on this we are going to split the array, divide the array. Okay, this is how divide and conquer methods in this binary search. So you are going to divide the array into subparts in order to search this particular element. Right, so now compared to 16, 52 is greater. If 52 is greater than the 16, you need to proceed towards right hand side. So here this right hand side array is now taken as my sub array. So this is my subarray. In this subarray, again what I should do? I need to find the middle element. There are 3 elements in the array. If in that case, this is my middle element. That is 36 is my middle element. Again you need to compare 52 with 36 whether it is equal or not. If it is equal, return this value as a result directly. If it is not equal, again move towards right side. Why we are moving towards right side? Because 52 is greater than 36. If the value, key value is greater than the middle value, move towards right. So coming to right side, again this will be divided into my sub array which has only one element. So this will be my middle element, this will be my low, and this will be my high. Okay, that is, this will be my starting as well as ending. Now I need to compare this 52 with this middle value 52. If both are equal, then I'll return this as my result. Okay, so this is how binary search works. And if you see this array, initially for this array, we will consider this index, starting index 0 as my low value, and the last index, that is size minus 1, will be considered as high value, and this is my middle value, right? This is what in the initial array. But once the array gets divided, now my middle value also changed and my low value also gets changed. But what about my high value? High value will not change if it is right hand side. What if the value is divided based on the left hand side? So then this will be my sub array, and in this array low value will not get changed. It is kept as it is, whereas my middle value will get changed and my high value gets changed. Okay, and if you see here, coming to this side, so my low value gets changed when the array gets divided into the right side. So what is the low value now? You can see this is middle value. So middle value plus 1 position is my low value. So how can I write middle value? Low value, middle plus 1. In the same way, here my high value gets changed if the array is left side. So if you take high value, how can you write this high value? Middle value minus 1 position. So I can give middle value minus 1 is equal to high in my new sub array, that is at the left hand side. If it is right hand side, low value is equal to mid plus 1. So based on this, we are going to write the algorithm for binary search. So you can implement binary search algorithm in 2 ways. One is by iterative method and the other one is by recursive method. So we'll see what is iterative method first. If you look at this method, here is my method name, that is binary search, where I am passing the array and key, that is the key value to be searched for, and what is the low value and what is the high value. So this is my method and this is the block of my method. Inside this you can see, first you are going to check the condition that whether low value is less than or equal to high. If low value is less than or equal to high, then we are going to proceed with this one. If this low value is greater than high, we are not going to do anything, because this indicates that your array, like the high, you have your low value gets exceeded the high value. That can't be possible, right? So which means there are no elements in the array to be searched for. So always low value should be less than or equal to high. If in that case, we can go for doing binary search. So what is the first step we do for binary search? First we need to find the middle value. So how do we find the middle value? By using this formula, that is low plus high divided by 2. So once you found out the middle value, now you will start your comparison. So what is our first comparison? We need to compare whether the given key value is equal to the middle element of your array. If it is equal to middle element of your array, directly you will return that middle element as your result, as output. If not, then what condition you need to check? You need to check whether the key value is greater than array of mid or the key value is less than the array of mid. So that is the condition checked here. You are checking whether your key value is greater than array of mid. What if key value is greater than array of mid? You need to proceed to the right hand side of the array, that is your array gets subdivided into the right hand side. So in the right hand side, what are all the changes we have seen? middle value will also get changed, and then low values also gets changed. Now here you can see what I have done, that is low value I changed it to middle plus 1. Okay, so I already discussed that when you are going to right hand side, the low value will be changed to middle plus 1. So that is what given here, middle plus 1. So this is for key value greater than middle value. What if key value is lesser than middle value? Then we'll move for the left hand side. If you're going for left hand side, high value gets changed. So how does the high value gets changed? It is equal to mid minus 1. So the left hand side, in the left hand side, the high value gets changed to mid minus 1. So this is how the iterative method works. The same code we are going to do in a recursive method. So this is what a recursive method. So first you should understand what is recursive method, what is meant by recursion. So generally recursion means a function that calls itself is called as a recursion or recursive function. Here you can see in this function we have recursive functions, like this function is actually binary search. Okay, inside this block you can see again I have a function called binary search, which means this function is calling itself again one more statement which is calling itself. So this function is called as a recursive function. Okay, the same thing I have taken array and key value, low value and high value. First you need to check the low value is greater than high value. If the low value is greater than high value, then you are not going to do anything. But if the low value is less than or equal to high value, then you are going to find the middle value. So how do you find middle value? Just by taking low plus high divided by 2, then you will find the mid value. After finding the middle value, same thing, we are comparing the key value with middle value. If it is equal, return the value, otherwise go for checking the other condition, that is key value greater than mid value. If key value is greater than mid value, then you are moving towards right hand side. If you are moving right hand side, you need to change the value of low. Here you can see in the function call, in the parameters, I just changed the value of low. Okay, I just changed the value of low to mid plus 1. Now this is my low value. High value is same. And what if key value is less than array of mid? So if key value is less than array of mid, you are not going to change the low value, which is kept as it is. Whereas coming to high value, you have changed the high value to mid minus 1. So this is how a recursive method works. And here is the time complexity of binary search. So when we take binary search, how can we represent the binary search in the form of tree? So you can see this is my middle element. So 16 is my middle element, and this again gets divided into 2 subarrays. And if you take these 2 subarrays, again in this 2 subarray we have a middle element. So now 5 is my middle element at the left hand side and 36 is the middle element in the right hand side. Again this gets divided into subarrays. This also gets divided into subarrays. So in the left of 5 we have 2 and in the right of 5 we have 9. Same for 36, left side it is 18 and right side it is 52. So here this is how you have you formed a tree, constructed a binary search tree with these array elements, right? Now when you are performing any operation on the tree, binary search tree, so this operation completely depends on the height of the tree. So the height of the tree can be given as log n. Okay, now I am finding the recurrence relation for this one. So the recurrence relation is T of n is equal to T of n divided by 2 plus 1. Here T of n divided by 2 means you are going to divide the array into two subhalves and you are comparing only in the one half. Because if the value is less than 16, you are not going to search in this right subtree. You will be searching only in the left hand side. So only it is happening in one side, in one half of the values. So that is why it is given as T of n divided by 2 plus 1. 1 is for checking the condition, that is comparison. Okay, so based on this recurrence relation, we'll be finding the time complexity of this binary search. So if you see this recurrence relation, it is similar to the Master's theorem in the format of Master's theorem. So if you don't know about the Master's theorem, I have discussed about it in the previous video. So go and check it once so that you will understand how to find the time complexity by applying Master's theorem. So if you apply this in the Master's theorem, then you will get this as the time complexity, that is big O of log n as the time complexity for average case and worst case, whereas the best case time complexity is big O of 1. Because what if I want to search for the key value 16? Okay, if you take 16, in the first step itself we'll obtain that value, whatever the value we are searching, that will be in the first place itself. So the time taken will be big O of n. This is what the best case. But when it comes to average case and worst case, the time complexity will be log n, which is completely based on the height of the tree. Right? Thank you.